Jay, working on the Holoseat test rig some more. Tonight I am extending previous demonstration videos where we exercised the Arduino that drives the stepper motor just directly from the Arduino IDE and the serial port monitor. If you'll recall, we can send values over the serial port line to the Arduino, and it will interpret those as commands to turn the stepper motor at that specified number of steps per minute. And that with two magnets, one on each end of the boom there, we anticipate getting double the cadence out of our tests, and we have the same cadence computer. But this time, now we also have a Raspberry Pi 2B to be used as the control system for the tests. And the Raspberry Pi needs to do a couple of things. The first is that it needs to be able to read and write to its own pins from our test scripts so that we can measure values during the tests for sensor performance. And then the other thing is it needs to be able to communicate over the serial I/O over USB to the Arduino so that we can send speed commands for various tests to the stepper motor. So I'm going to do two demonstrations here. One that shows operating the pins by blinking an LED, and the other that demonstrates sending serial commands to the Arduinos in order to turn the stepper motor. We'll again have the cadence computer so we can see that we're getting the anticipated values. Remember that because we have two magnets, one on each end of the boom there, we're going to get twice the specified cadence in order to get faster speeds than in our sensor test than the stepper motor can do with the current rig. Note all this is being done in node.js using Johnny 5 and raspi-io and node-serialport. So the first thing I'm going to do is run a blink script that will tell that LED over there to blink. There we have a blinking LED. If I stop the code, the LED stops blinking. In this case, it stopped blinking in the on position. All right, now the other test I want to do is to run the simulation here of the bike pedaling. So I'm going to start with a value, passing a value of 20 over the serial line, which should give us a cadence of roughly 40. And so we have to wait for a moment while it initializes, and then away we go. And we can see now the cadence computer has caught up. It's gotten enough data points. We are showing 39. And if we send 10, we should see 20. Stop for now while it resets. And indeed we do see 20. And then obviously if we send 15, we would expect to get 30. Here we are. And then we can set it to 0 to completely end it. And then you can see the commands 20, 10, 15, 0. So there you go. We can now do end-to-end controlling of all the important bits between the Raspberry Pi and the Arduino from our node.js source code. So we are ready to start demonstrating things in the direction of actually building test scripts.